Hello, everybody, and welcome to a mildly late starting edition of Solidity Fridays. Today, we'll be looking at Ross Campbell's Helios, which was a very interesting idea that I hope to see a lot more traction of. I guess just to give it like a little bit of motivation. ERC1155 is kind of famous as an NFT standard, which of course inspires endless discussions about what the word fungible means. But really, if you take a look through the standard itself and kind of like dig into its history, it was clearly envisioned as being kind of almost a mix between ERC and ERC 721. So you have both non-fungible and fungible assets inside the same contract. What Ross thought of was maybe creating an entire AMM, so something like a Uniswap, inside a 115 contract. Like normally with Uniswap, each pair that you have, so like USDC DAI, but then also say DAI USDT or something like that, each one has its own contract. So instead of giving each one their own contract, give each one their own index inside of a 1155 contract or something of that general sort. We'll see the details shortly. And then kind of use that so that all swaps are happening inside the same contract, as opposed to having to basically have this sprawling ecosystem of contracts. And we figure that what we will take a look at today. Ben, anything you want to add to that?
No, I mean, I'm coming in completely blind here. I think you have a lot more context than me.
We just got through all my context.
Oh, okay, we're out of context. Sweet. Okay, well then, I mean, that was actually informative for me. And that sounds like a really sick idea to have an AMM. I guess it's an AMM and not some sort of order book type DEX. That built into where the tokens and the fungible tokens are sort of those different, as you say, indexes or
IDs if we're using the official 5 thing, because of course, like it's for some reason 721 and 1155 have like a bit of an argument about nomenclature, like it's token ID in 721, then it's ID in 1155.
Yeah.
But yeah.
Cool. And you can use raw ETH too. Interesting. Okay, well that probably just a little bit of an edge case there.
Other than that, not much going on in the README, I see.
Yeah, the contributors, go follow him. Yeah,
cool.
What
looks like a simple hard hat repo.
Yeah,
this was before Foundry.
Let's take is it before Foundry? I mean,
I believe that it is.
Because like
I see that one there from 2 months ago.
Fair enough.
Summer 2021, maybe. When did, like, oh no, I can't tell time anymore, man. When was Foundry launched?
December 2021. That is ages ago in crypto time.
Yeah, I can't tell time anymore. I have no idea how long Foundry's been around for either.
No,
I feel like that's right around when Foundry launched, but I could be wrong.
I think Foundry started getting kind of popular around then, but well, maybe a bit after that actually. Sorry.
Yeah. Okay. Cool. So let's jump into. Do you want to say anything about like the package JSON or the hard hat config?
I was just going to check it out.
Hard hat config. Yeah, let's take a look at it.
This is pretty cool. Named accounts. I'm just been
interesting
into hard hat configs before, because there's some interesting. You find like cool cheat codes every now and then. Actually help a lot with like setting up those repos.
Oh my gosh, and his API key. Scroll up.
God. Docs. Sorry, Ross.
Rip your alchemy key, dude. Sorry.
Okay. Let's
just remember, kids, never push your API keys to GitHub.
Oh no. Okay, let's move on to the contracts, I think.
Last commit was yesterday. This is actually actively maintained. I had thought it was kind of just like a cool proof of concept. But it sounds like he's actually actively maintaining this.
All right. Where are we? Contracts. All right. So do we do Helios or this?
I think the 1155 first, but I could be wrong.
See if there's anything special here, and I'll pop this up in another tab. Okay, 1155. So we're starting off 0.8.4 Solidity, so nice and modern, as you might have guessed from those commit dates. Nice. We're using Soulmate. Okay, good to see. Right. This is pretty standard, just interface stuff for the 1155. So specifying that a contract can receive it, and those hooks.
Mhm.
So
And I'm assuming that's going to be for LP tokens, because the LP tokens will now be 1155 thingies.
I suppose, hey, that's interesting because
That's a big guess.
That's actually like kind of trippy to think about, because it's the actual underlying assets in the AMM are like sort of slots in the 1155. So how do you represent that you own liquidity in those slots? You then mint another 1155 for the LP tokens.
I'm assuming that they're going to have some kind of struct attached to each ID that kind of monitors the assets. I mean, the assets can only belong to the contract, right? So I'm assuming all the assets kind of sit in the contract. So even if you have like, you know, a DAI ETH pool and a DAI USDC pool and a DAI whatever pool, that all that DAI is just, you know, sitting together. But a struct on each ID kind of monitors it and monitors the ratio between the two assets. But then the actual NFT, well, or not, we're talking about using this as a completely fungible asset, but the LP tokens are kind of the amount of ETH that you can own.
Yeah. Okay. So
that makes sense. Hope that made sense.
Yes. I think you're right, and I think when we assume now that they're going to be fungible LP tokens, we're not doing anything like Uniswap v3 fancy level, with sort of concentrated liquidity, which would cause non-fungible tokens usually for the LP tokens. So I'm assuming what he's going for here is just like a simplified kind of just X times Y equals K Uniswap v2 type deck.
V2, yeah. And I thought for a long time that the reason why 1155 didn't get as much traction in ERC20 land, like using it for fungible tokens, was just because no one felt like building out the tooling for it. You know what I mean? We're already used to thinking of one address, one token, and all of that, and then having to come up with like knowing an address and an ID for a token, just no one felt like building out. But I do wonder if projects like this can actually kind of even nudge towards where that is more of a thing. Like if you think about it, you could have all your tokens in one contract instead of spreading them out. It's just a matter of having the tooling to deal with it.
Yeah, well, I mean, it's hard to get people to standardize on a particular contract. This is like, you know, the OpenSea contract or the Coinbase contract or whatever. It's some big name behind it. So I think it would still be fragmented. And then
you can build out support for both.
Yeah,
you know what I mean? Especially because 1155 supports X5. So you can always just check if it supports interface. And then if it supports interface, then do like, you know, ID in addition to just address.
Yeah. Interesting. Okay, so continuing on, it looks like this is just the abstract ERC 1155. So he will be inheriting from this in Helios, I imagine, and we can see that there. Okay, there we go.
Okay.
So this is where all the juicy parts.
Oh, and multi-call. Interesting.
If we have time on this, we get through things. Maybe we should just dive into multi-call in general.
It's usually a very short contract, actually. I wouldn't mind hopping straight into it.
Okay. Sweet. But let's.
You want to do this first? All right, let's do it then.
He said that it's a minimized and gas efficient or modified soulmate contract of the ERC 1155, and it supports meta transactions. So this could be interesting. So
that's interesting. I don't remember. Does Soulmates 1155 support permit style transfers? Because I see he's like talking about SIG expired and invalid and things like that in there. Makes me think that there's probably some what's it called going on over there? Some permits going on over there.
I remember at least the ERC20 has permit.
Yeah, the 721 has permits built into it. I seem to remember.
Let's check this out. No, it doesn't have the meta transaction stuff. So that
interesting.
That's what he's added here, I guess.
Yeah, I'm assuming.
And then we.
Oh wait, no, there you have SIG expired, SIG used. Yeah, EIP 2612 like storage. They do it.
Well,
right there in 7172.
This is Ross's one now.
Oh, we're back to Ross. I didn't realize you control tabbed out. Okay, got it.
So here I'm in the normal one.
Yeah.
And in the events, you can see there's no events or errors. Well, I don't think transmissions likes what are these
Custom errors.
custom errors. Yeah.
Oh yeah.
Yeah. So
Huh.
I just saw a little Twitter conversation about it, and Ross was like, "Oh, one day you'll win him over." Um, yeah, but yeah, you can see. So that does seem to be the addition is the meta transactions and the permit stuff.
Hmm.
Cool. Okay, and so that for that we need to have the domain separator and the chain ID, which is nice.
Mhm.
Cool. That's all fine.
So the chain ID actually you don't need to save, but I think he's going to do a cool trick that I think I originally saw in Soulmate in their ERC20, which is you kind of want to set your domain separator in the constructor. This is such a tangent. I'll try and make this really fast. You kind of want to set your domain separator in the constructor just so it's set. You don't have to compute it each time. But if the chain forks, then you'll actually be able to replay between the two chains because you already set your chain ID constructor. Now it's immutable and it's never going to change. So what Soulmate does, because that's kind of an extreme edge case, but you still would want to protect against it, is they set the domain separator in the constructor and save the original chain ID. And then every time you use the domain separator, you use a ternary saying, is the chain ID still the same as it was like back when we set this? If so, you don't need to compute the domain separator, just use the saved one. Otherwise, compute it fresh. And that way you add an if every time that you use it, but at the same time, most of the time you won't actually have to compute it again. So you won't have to like go through like the packing and the cat checking and like
the packing and the kachak.
I thought was yeah, that's right.
Yeah, that's elegant. That's nice, and you get the security and a decent amount of gas efficiency. Sweet. Okay, I think that sort of let's go just check out the the safe transfer from, or would it be a different function? Yeah, permit. Okay, so there's the permit.
Yep. Looks pretty permitty.
Permitty, yep.
Unchecked, man. Living on the edge. I guess it's 32 also is overflow. Huh.
This is a nice base ERC 1155. Like, I would maybe come here for future NFT.
Yeah.
Yeah. Sweet. I think are we good here? Otherwise, everything is else.
I think so.
It's pretty standard.
Yeah, I think so.
1155. Cool. Let's give it one last little squiz. Yeah, looks standard to me. All right, so Helios.
Batch burn might be new also. I just caught that at the end. Doesn't make much of a difference though. Let's hop into Helios.
Okay. Cool. For liquidity pairs.
Yeah, it probably does have mint and burn functions like implemented, but like top level, not just an internal.
Yeah.
Because you'll need those to be able to just mint new LP tokens and all that. Yeah. Using safe transfer lib for address. Okay. Interesting for address, not for ERC20.
Huh. Well, I guess
it casts it.
Yeah, you would. I mean, you could use an address without calling those functions, right? So you aren't forced to use those functions when you like using an address. Right.
No, it's just interesting to me. Like, I wonder what the advantages of using it on address as opposed to ERC20. What I thought on ERC20 is, I don't know. I guess it depends how a library loads. Like, let's say you use an address normally. Is there any extra check there to say, like, oh, maybe it's a safe transfer lib library? Probably not. I can't imagine, actually. You probably don't lose anything there. Yeah. Cool. New events, pair created, liquidity added, liquidity removed and swapped. Interesting. Okay.
That's pretty Uni v2. Yep. Here is identical token. Okay, so in Uni v2, it won't let you, I think, create an LP It won't let you create a new pair contract.
New pool of a new pair on the same that already is created. So like if you already have ETH DAI, you can't make another ETH DAI.
Yeah, the same tokens, because what it does is it sorts those two addresses of those two tokens alphabetically, and I guess it does create two to create that contract. So it's sort of derived from those two addresses, and you would always end up with the same address. So it's deterministic what the address of the pair contract would be. So yeah, so you can't. Yeah, but maybe this might also mean like both sides of the pair are the same token. So I don't know what they mean by this error actually.
Be interesting to see. Just to see.
No swapper pair exists. This is probably what we were talking about. The pair exists.
Yeah.
No pair. Interesting. No liquidity.
I guess if you try and swap and there's just no pair for it.
Yeah.
I wonder if that means he mentioned something in a tweet, I think, about routing. So like theoretically, if you've got routing, even if you don't have a specific pair, you should be able to route through multiple pairs. And routing through multiple pairs actually should be somewhere where this really shines, if we're right, that everything just kind of exists in pools.
Yeah. Well, yeah, I mean, you're having to go.
You don't have to transfer on multiple contracts.
Yeah, exactly. So it should be quite gas efficient if crossing more complex routes.
Yeah.
Okay, interesting.
Probably do have to write to structs on each one, though, because you'll have to update each struct that you're touching.
Yeah. I mean, that's still...
But you'll save all the transfers, which is amazing.
Yes. Okay. So, I mean, this looks like it's going to be... it's actually not that deep. It's 279.
Yeah.
That's
not...
Wow.
I mean, especially when you're doing full NAT spec. I mean, like, look at that. You just passed, 15 lines of comments right there, you know?
That's pretty impressively elegant. All right. So let's get into it. So we have standard total supply.
The new gang all likes using public. It's so interesting. I remember back in the day when everybody coded Solidity globals with private and made getters for them. But yeah, I guess public's like the new thing.
Well, it's the compiler, I think, in 0.8 isn't inefficient about that anymore. It knows.
Is that why it changed?
I think so.
Man, I didn't realize that. I just thought it was like, new kids on the block didn't mind.
Don't care as much about saving gas anymore or saving contracts.
I don't know, like everybody's got their hill, you know what I mean?
No, it actually, now these days, it doesn't, there's no difference in contract size. Or
oh, wow. Okay. I'm officially a Solidity boomer, my God.
Okay, boomer. What is the default? Is the default public? Because I see here there's no keyword.
I'm not, I was trying to remember something. You can't really figure that. I think it's a mistake, to be honest, because on 47 he's got public, and then on 49 he's got private. So I'm assuming he just forgot to put there what he wanted.
Yeah, I assume it's public. Actually, I don't know.
I think default visibility is public. That sounds right. Yeah, default visibility being public sounds right.
How's chat doing? Just chat no. Chat. Tell us what the default visibility of a mapping is, please.
Chat like Siri, chat.
Chat.
Yeah, won't we keep on going in the meantime?
Okay. Sweet. So what is this total supply then? Because it says tracks new LP IDs. Is this like an increment?
I'm not sure. That's a good question. The total number of pools, which isn't like the greatest definition of total supply in my humble opinion, but since it says in the NAT spec that it's tracking new LP, I'm assuming I'm like kind of the token counter for this.
Yeah, we could probably check that out pretty easily if we see this sort of thing. There we go.
When the visibility is not specified, the default visibility. It's talking functions as opposed to globals there, but I assume it's the same.
You're cutting out there. What was the default?
Default visibility seems to be public.
Yeah. Okay. Cool. Nice. And then, so just to confirm our suspicions, it looks like total supply is an ID, sort of an incrementing ID, as you can see here.
Okay, cool. Yeah, bit of an interesting name choice there, though.
Sweet. Okay. Yeah. I think that's interesting. And then here we have tracking the LP amount per ID. So then I think this is
that's much easier to understand.
Yeah.
It's like the LP tokens for each ID.
Yeah. Per ID. Yes. Okay. Cool. So that this figure, this event would be the ID that probably comes within this range, and then this figure would be that fungible sort of balance of the pool. Yes, of the liquidity.
Exactly.
Yeah. Okay. And again, I think this is
each one has its pair struct. Yeah, so that's kind of what I was expecting. I was kind of expecting a struct for each pair, and we're gonna see what that struct is momentarily. And then wow,
look at this 4
quad mapping. My gosh.
Ross. All right.
Address to address to interface to
I mean, okay, so I assume this is someone's account. I don't know what this address is.
I don't know. I pair swap. The interfaces were up above, weren't they? Or they put them on the bottom? Like, what's that I pair swap?
That's a good question. Because it does seem to use this. Okay. Pair swap, add
liquidity, remove liquidity, and swap.
That might be coming from a library.
Oh, I'm thinking back to the tweet that he mentioned. I think this might be to allow it to plug into other AMMs.
Oh, there we go. XYK swapper. So this is probably what we're missing here.
XYK swapper modified from Uniswap V2.
There we go. There's the add liquidity, the remove liquidity.
This is what it's being handled. Oh, okay. All right. So they're like basically. So what happens? Each ID has its own
let's go back
discrete contract. The map. This needs different contracts. So it's just being stored in Helios.
I pair swap. I mean, yeah. So this is an address as well, right? So it's address. But this one is just an I pair swap.
Oh, I bet that's the token pair. So you have like your token 0 and token 1. Okay. And probably just do whichever one is greater than or less than the other is 0, like Uniswap does.
Yes, yeah.
And then that maps to setting. And then that maps to 2U and 256s. Who knows why? All right, we have to figure that out, I think.
I think one of these has to be, I think this is the user address. Because I mean, isn't this their LP balances?
I don't think
so. No, sorry, this is pair settings. Okay, fair enough.
But I think we're gonna have to figure that one out on the fly.
Yeah. Because like what are the two, I mean, what is the
The 2 UNs got it's totally got me there.
Okay, interesting. This is a little bit of a puzzle. Chat.
And it's private.
If you have theories, chat, please. Please, chat.
Siri, what's this purple nested?
Siri. Chat, explain the code. Okay. All right, so should we just...
Welcome to Solidity Fridays, where we sit around and ask chat to explain the Solidity code.
Should we just keep going down?
Yeah. So let's take a look at what the critical parts of the pair struct are. So we've got token 0, token 1 as popularized by Uniswap, the I pair swapper, which he calls pair output target.
That is interesting.
I think what they mean by that is just that it when you're swapping, it'll output a lot of the details to there and do the math there.
Yeah, so it does.
Because I'm pretty sure that's what the. Sorry, yeah.
Yeah, I think we're probably on the same page where this targets some deployed swap library. In this case, it might be the XYK swapper.
XYK swapper, yeah, I think that's exactly it.
Okay. Cool. And then that could be a different one. That could be a concentrated liquidity thing or something.
Then there's the amounts of each token in the pool. I'm assuming that's reserve 0, reserve 1, and the cool. All right.
You cut out there at the end, but I think.
Oh, I was just reading it. Yeah.
All right. So the interesting struct packing that we've got here as well, which is quite nice. So these, I believe, are.
I forget each time. I feel so embarrassed.
I think it's 200 bits per address. So that's. Oh, 160. 160, yes. 160 bits per address, because that's 20 bytes. 20 bytes out of the 32 in the slot. So none of these don't pack. Those all take up slots. And then these, so you get your 224 plus 8.
8 is 232, which is, I mean
that's fine.
Still gonna.
You get one slot.
They'll pack that all in. Yeah, I should pack it all in one.
You could probably increase this, but like it doesn't matter because your fees.
If you don't need to, you don't need to. Yeah, like you don't really gain anything by it. You're still gonna have to cast it.
Yeah, I wonder what the reasoning behind the 112 UENT is here, for like a reserve. Why specifically 112 instead of like 128? Then there wouldn't be space, I guess, to do this fee. Interesting.
For some reason, I feel like I see that number around 112.
Yeah, I also that's like partly why I'm questioning is it seems somewhat standard. Maybe it's just standard because this is often the packing that goes on, 2 112s and then some other piece of data.
I'm literally searching why is 112. All right.
Why is 112?
Why is 112? All right. Let's see how we create a new Helios liquidity pair.
Cool. Okay.
All right. So you can put then token A and token B in any order, and it will sort it itself. I believe Uniswap authorized that. The amount of each. Swapper, the contract that provides swapping logic for LP. Designated fee. Okay. Data bytecode provided for the recipient Helios liquidity. Interesting.
So this might be similar to what we saw in the last thing with Lens protocol. I'm assuming this gets passed on to some.
And we saw that he's inheriting from multi-call.
Yes. Oh, yes, the multi-call. So this could be.
That feels like something there.
Let's look at
this. But it doesn't have to do with ETH, which is interesting, being that he specified that you can use ETH as opposed to ETH here. It is payable also, which just kind of reinforces that. It's interesting. This is a virtual function, so I guess this contract is not meant to be deployed as is.
There's the data passed into the mint for the 1155.
So we'll have to on there because mint. I mean, traditionally, first of all, mint isn't a specified function because you don't have to have it. But most mints I see do not pass in arbitrary data.
I've seen it before. I think in the standard Soulmate.
From mint.
Yeah. I guess it's to do something on these.
Correct, sir.
Yeah. So yeah, if you have some sort of custom logic that you want to do on the 115 received hook or whatever, that could come from this data on mint. So yeah. But
solid point.
I don't think it's super relevant here, maybe.
There's probably interesting things you could do with that. I mean, I've kind of felt that about data in general. I kind of feel like the data field in 721 and 1155 is, I'm glad it's there, but I feel like we haven't really gotten to a point where people are really leveraging it.
Yeah, it's always this like mysterious parameter in a function. I'm like, ooh, data. What could the possibilities be?
Empty string. Yeah, inevitably. Yeah. All right, cool.
All right. So wait, I think we skipped ahead here. Do you want to dig into this some more?
Yeah, let's dig in.
All right.
So, and here we have die. You can't make a pair between die and die on line 85.
Yeah.
I thought that might be it. It's interesting. I wonder why he can't let people do this. I wonder if this is one of these cases where you're kind of deciding to save users from themselves. Like, I wonder what would happen if someone did make a die-to-die pool. Like, would something break?
I guess you're just losing money, right? Because it's like, here is my token.
And anyone who uses it will lose money.
Yeah,
because they'll get charged more than one die per die.
Yeah, you just take a fee. You slowly just drain the thing. Like, there's no point in swapping because you just lose money on each swap.
Yeah. Yeah, but okay. So he reverts on that. If address swapper is address 0, then there's no swapper. Similarly, if there's no code length there, so that also means there's no swapper. Okay. Sort tokens and amounts. It's interesting he doesn't use 165 for this, in my humble opinion, because the way that the code exists right now, theoretically, if somebody would point at an invalid swapper, it would work. Like if they pointed at some other code, I don't know, like, compound, like take your pick. There would be code there and it's not address 0, so it would actually register it as the swapper. If you're using 165, I mean, 165 can be cheated too. It's certainly it definitely doesn't absolutely guarantee everything, but then at least it'd have to be a contract trying to signal that it's a swapper.
Yeah, but I mean, I think it's going to revert at some point. Swapper.add liquidity, like.
Yeah. Oh, so you're saying you always fully revert over there anyway. But then why make the check if you're just counting on the revert?
Probably to save on gas if it's like, I don't know. Yeah.
But if someone's not even putting that, do you really care about their gas? I guess. Yeah, either way.
Yeah.
Okay, set tokens and amounts. Token 0 and token 1 start off as token A and token B. The amounts start off as token amount, token amount. Okay. If token B is greater than token A. So this is the Uniswap sort. So the way that you sort token 0 and token 1 is, I mean, addresses, if you think about it, are theoretically a hexadecimal number. We just don't look at them that way. So it just sorts whichever address is bigger is always going to be address 0.
Yep.
Did I cut out there?
No.
I was getting... Okay, cool.
No, that's a good explanation of this little sort thing going on here. And then we just also sort those amounts and keep them sort of aligned with the token 0 and the token 1.
Mm. And then it just checks if the pair exists. I'm guessing the fee has to be above 0 because otherwise that check won't work.
So here we have the explanation for our mapping.
Oh, good call.
Yeah. So okay, so it is the 2 tokens.
And then the swapper.
And then it's the fee, interestingly. Okay, so you could have...
It's the amount of fees that have been accumulated.
No. It's I think it's the fee setting. So you can have the
last one. The fee, I agree with you, but I'm saying the last UN. I meant the last UN. The last UN is the amount of fees accumulated, no?
Pair exists. As
in, you could have 2 DAI ETH pools if they have different fees.
Yeah. That's yes. So I mean, this fee is the setting, is the how many basis points are we taking off, right? So how UniV3 does it, where you can create pools of the same pair but taking different fees. So what is this? The output number, that final unit in the mapping, is what I'm thinking. Is that?
I suspect how many fees have been collected. I could be wrong.
Either that or it's liquidity, but that doesn't make sense to be one. It doesn't make sense to be one number.
Right. My big problem with it being fees collected is what if 2 people try making the same pool in the same block? Because it shouldn't have collected fees yet. So fees would still be at 0. And if that's the only thing you do to check that the pair exists, I don't know. I could have imagined
it would
using a bool for this, like an exist bool inside the struct.
Oh, when you create a pair, don't you have to add a certain level of liquidity.
Oh, wait a second. Take a look at 111.
111.
It's the ID.
Ah, there we go.
And that's why it isn't 0. So I guess he's not. I guess minting starts at 1, not at 0. Awesome.
Okay. Phew. Chat, you really are seeing us crawl around in the dark on this one.
I don't know. I think we're doing pretty good for coming in cold.
Yeah.
I think about it. Like we're only like how many minutes in? I can't do math. 35 minutes in or so, and we're actually like 100 lines of code in. Like this is wild.
This is really good for us.
Yeah.
Compared to like Lens Protocol, we're stuck on documentation for 1.5 episodes. Yeah.
All right. So now we're gonna have some ETH stuff here. So if ETH is attached, overwrite token 0 and token 0 amount. So ETH is automatically token 0. So if message value is not 0, token 0 is the 0 address. So ETH is the 0 address essentially internally. You can put in whatever you feel like is one of the token amounts. Does it have to be token 1? I wonder if it. Oh, so okay, token 0. Okay, token A. It won't make a difference. No, wait a second. This is a bit funny. Say I fill in both token addresses and I send in ETH. So I mean, like there is a token A argument and a token B argument. So I do have to fill those in. So like, let's say I fill in DAI USDC and send in ETH.
Well, then it would default to ETH, I think. Like the sending in the ETH overrides it looks like. Yeah.
Right, but I'm debating, does that end up being an ETH USDC pool or an ETH DAI pool? I think the answer is it's going to be ETH in whichever has the lower numbered address.
Yeah, because it would do this, right?
The higher number address automatically becomes token 0, and then token 0 gets overwritten.
Yeah. So yeah, it does the sort for those two pairs or those two tokens that you send in, and it will take the token 1 of those two after being sorted, and token 0 will default to address 0, which is ETH. Yeah.
Token 0. No, 12. Interesting, though. It's interesting that he does this here after the sort.
Yeah.
Because that means that he's writing token 0 once and token 0 amount once, and then he's rewriting them. Oh, but it's writing if it's 0. So I guess you assume that the person's going to put in the 0 address. Oh, wait, but this is a... Oh, wait, no. This is what I... Yeah. You don't want to put in the 0 address. You want to put in like 0xFFFF as the other address. So like think about it. Let's say you want to make an ETH DAI pool. So if you put in address 0 and DAI as your two addresses, DAI is automatically going to become address 0 because it's going to be token 0 because it's bigger than address 0. I mean, that's a given. Address 0 is the lowest number out there. And it's going to get overwritten. So what you have to do then is pass in one of the token addresses being 0xFFFFFF, no?
You might be right. I mean, I'm also thinking there's...
I honestly, like, I mean, Ross, if you ever listen to this, you're the man. But I'm wondering if it would have been better to use a less than as opposed to for the story.
Yeah. I'm going to check the tests. Oh my gosh. Ross. Yeah. Maybe we should write up.
Well, they are still actively contributing to it. We probably should point that out. Yeah.
Fair enough. But yeah, good call, William. I would try and check that.
If anybody wants to become an official contributor, you know.
Yeah. This might need to change direction. I would just verify with the test, trying passing in, what is it, address 0 as token.
As either, really.
I didn't
like,
like that. Could you try again?
What? Siri, go away.
Siri is going to do Solidity in the end. Like, try pass in, I would say, address 0 and DAI. And then try and pass in 0xF, etc., DAI. And like seeing what works over here. It could be the assumption just is that the front ends that are communicating over here will pass in 0xFFFF whenever you're doing ETH. It's just address 0 is so much easier to work with.
Yeah.
You
No, I
know, like
agree.
you've got a constant for it in ethers, like that kind of stuff.
Yeah, I like using address zero for ETH to represent like the ETH in the if
Mhm.
statement. But yeah, I think you're probably right, and just sort of double checking the sorting thing, considering that one of them will be overwritten with address zero. And so if you
Mhm.
do kind of go into this assuming you're putting in address zero for one of them for ETH, to say it's ETH, and you pass in some ETH in the message.value, there's a little bit of like a foot gun that exists here.
Yeah.
Yeah. Okay.
Cool. But then it transfers in, and it transfers into the other asset as ETH. And then else if there's no ether being put in here, so then it just safe transfers from both.
Yep.
Going from message sender to address this for the token amount. Yeah, that all makes sense.
Yep.
ID plus here.
Gas efficient.
Yeah. Wait a second. Can you scroll up a sec again?
Sure.
As in, we're getting the ID plus here and okay, yeah. All right, fine. Yeah. Sorry, that was just like
add it.
brain.
This is we
You increment before you set it, which means that it'll start from ID 1, not ID 0. That's all I wanted to see.
Yeah, exactly. Cool. That's fine. And then so we.
They have to even because of the way they're checking if pair exists.
Yeah.
That was kind of the cool catch.
Up here. There we go.
Yeah, like if you'd start from ID 0, your first pool would be in trouble. It would never work. You'd never be able to get started.
Yeah.
And then it writes the struct.
Sweet.
Makes sense. Token 0, token 1, the swapper, token 0 amount, token 1 amount. So it's interesting. I was kind of expecting the create to deploy a swapper, but it sounds like you actually have to do that separately, which is also interesting. Like you pass in the address.
Wait, say it
I
again.
kind of wonder where that is too. The swapper thing, there's like this other contract that's kind of the library for the math. Yep. I was kind of expecting originally before we started the function that calling create would deploy it. But I'm guessing there's a stack too deep issue with that or something like that. Unless you passed it in as an array.
Were you expecting to have deployed the swapper in this function?
I was original, so I saw that it was one of the arguments.
I think the swapper is sort of independent, so there can be many swappers and then many pairs, and they have an independent relationship.
Right, but it is each pair has its swapper though, no? So when you created a pair, I thought maybe you could make a
you do
play a swapper for it.
Right. Yeah. Okay. Well, yeah. I mean, I think so. The swapper just
might just be
standalone, and then you point to it. You don't deploy.
Yeah. I mean, not a criticism. Like, also interesting.
Yeah. Nice. Cool. And then we just add that config, the pair struct. So we populate that and then add it to the. Is this a mapping? It is a mapping. Yeah, it's a mapping of ID to that pair.
Mm-hmm.
Yeah, cool.
What's this? LIQ? What's LIQ?
Liquidity.
I know, but like, what is it?
Okay, so I mean, it's probably the resulting like liquidity once you add liquidity. So you've created the pair and you've in amounts. So this probably gets you the resulting like a number liquidity figure.
Where was that set though? Is that a global variable?
No. It's
where's it declared?
Interesting. Good question. I didn't see that. And is it here? No. Oh, here we go. There we go.
Kind of
Finds it there.
Oh, there it is.
Yeah.
Yep. All right. Yeah. Nice one.
Yes, sir. Okay.
So that's the K, I guess.
Yeah. Yes.
Yeah.
Wait, no. It's not the.
Oh, yeah, you're right. It's not the K.
K is sort of an abstract thing, I think, where you multiply the two underlying liquidities of the tokens. So these would be the Y. K is these multiplied, but this is probably more like
The amount, it's the total supply.
Yeah.
It's the amount of liquidity tokens that are being made.
Yeah, it's the supply of the fungible liquidity tokens, I suppose. Yes. So that's what we're minting. We're minting
an amount of those. Yeah, 100%.
Yeah.
Yeah, and set that as the total supply on 132. Pair created. Hooray.
Hooray. Awesome. That was fun. I like this function.
Yeah.
Jeez. It's like actually it's very elegant how much Ross has managed to squeeze into like a 115
one contract.
Yeah,
like, and not even a gargantuan one. Like, I do agree with that. This is a really cool idea. So add liquidity. How do we do this? 2 ID, token 0 amount, token 1 amount. So no single side, just like Uni V2. Public payable.
Let me just
returns.
compare this. So you've got 2 ID, token 0 amount, token 1 amount, and data, of course. You have the same things here. But this time you're not specifying the tokens because you have an ID to point to that pair and the fee. The swapper has already been set for that pair as well. The fee has already been set for that pair. So yeah, okay, it's a subset of these arguments. Sweet. All right. Well, yeah, plus the ID to point to the relevant pair.
That doesn't mean you know what's token 0 and what's it called? Which one's token 0 and which one's token 1 though? To get them in the right order.
I mean, I would expect a sorting. No, it doesn't sort again. You kind of. Oh no, sorry. Yeah. So the ID points to those 2 tokens. Well, right? Because you get that here. You pass in that ID to the pair struct, to the pairs mapping. Sorry. And from there you get the 2 tokens. And then really what you're just specifying here is you're adding liquidity. So the amounts you're passing in of added liquidity for those corresponding tokens.
Right. So it's not hard to find.
Yeah.
You're not going to get sorted.
This is also, I noticed, this was the public mapping. So you'd be able to just read this off.
Right.
Yeah.
Cool. All right. So virtual again. If ID is greater than total supply. So yeah, again, that's as high as the IDs go. So revert no pair. You load the pair into storage because you're going to write to it. So memory. If base is address 0, assume ETH and override amount. If pair token is address 0, token amount equals, do you want 12 message value?
So this is, okay, here we...
Why isn't that plus equals on 157?
No, it's just overriding this figure. So whatever you've passed in here.
Oh, yeah. Okay. Yeah, you're right. I thought it was, all right, you got it.
Yeah, cool. Sweet. And then we just, having specified a message.value, the ETH is already kind of here in the contract, having been sent in this function call. And then we just transfer in the ERC20. Otherwise, we transfer in both the ERC20s. So sweet. That seems fine.
Yep.
We call on that pair, we get the swapper. And I guess this is where I suppose it's useful to have that, having used the... Oh, right. No, sorry. I'm thinking of the safe transfer lib for address, but that actually doesn't apply here. So we were actually using the swapper. Is it an interface? I think it's an interface. Yeah.
There is an interface for it. Yeah. That's what you meant. Yeah, I understand what you're saying now. Got it.
There we go. Just sort of, we're saying that when you retrieve the swapper parameter on the pair struct, you can
call the add liquidity function on it. Yeah.
That add liquidity function exists there because this is already that interface.
Yeah.
Okay.
So if liquidity equals 0, things reverts. Pair reserve 0. Interesting. Hmm.
What are you looking at here?
No, I was busy thinking, like, I think we'll know if you ever tried adding liquidity, so it has to be balanced. You know what I mean? You can't just arbitrarily add an amount of each. It has to be that it matches the ratio of the two assets in the pool right now. So I was kind of wondering what just put in arbitrary amounts of token 0 and token 1, but I'm assuming at that point add liquidity returns 0. And that's kind of where it flips out.
I mean, I think
that it actually needs to be balanced.
maybe. Where would this add liquidity? Where is it returning?
And that XYK swapper, yeah.
So it returns.
Oh, it's interesting, and it already reverts there also, which is
Yeah.
interesting.
So actually,
Kind of a double revert.
I don't think it would ever hit this.
The one in the it should never hit that one. I agree.
Yeah.
But then again, you could have a different swapper. There's
True.
no guarantee that they're using an XYK swapper. I wonder if that's part of the.
True. Good call. Yeah. Where I'm just curious as to in which case this would be 0. I mean, the one I'm thinking of is where you just pass in 2 zeros here as the amounts.
Mhm.
And it doesn't look like it does any checks for that. Math square root.
It'll flip.
So I think that would be the case if you pass in, or maybe if you pass in a 0 in either of them.
Close to, or anything that's under the min LP, you should also. But if you pass them precise, I think you might get a 0. Minimum token 0 amount times supply divided by reserve 0 token 1 amount times total supply.
So this would be a 0 of that, and then this division would result in a 0 as well. So you get 0 the whole way through, and it's the min as well. So yeah, I think at any point, if you pass in a 0 here, liquidity would be 0 and revert.
But it doesn't look like it checks the ratio, which is interesting. So that means that you should be able to deposit even not on the ratio.
Yeah.
And affect the ratio of the pool.
That is interesting. But I guess...
Does that feel gameable?
Well, so what you're getting here is you multiply those two numbers, I think. So you just get penalized.
Say USDC dipole for a second. So I add... Actually, no, that's a bad example just because those are stables.
Yeah.
But imagine that you had something like, I don't know, a wifey dipole.
Okay,
and you want to get wifey on the cheap. So you could add a ton of dye to very little wifey to disrupt the ratio. And then that should make the wifey cheaper to swap out. But I wonder if maybe the amount of dye the pool will costing.
So
just you'd save when you try and swap through.
What I'm thinking would happen is through this sort of multiplication and then square root, is you get the correct amount of LP tokens for adding those two unequal balances. And then if you sort of to do this arbitrage or whatever, if there was an arbitrage here, you would then just cash in your LP tokens and withdraw the underlying balances.
Right, but I'm saying, let's say you wanted to make for a better swap, you'd game the ratio so you can swap through cheaper. I don't know if the math works out though, and I have this is the base of Uniswap math.
I suspect you would kind of get an impermanent loss penalty on that.
Right, and it could be that you'll end up losing as much as you gained anyway, and it'll cancel each other out.
Yeah,
but I wonder if they're in that direction. My math is definitely still not sharp enough for that.
Yeah, but yeah, it would be interesting to see some actual mathematical modeling of that. But I'm just intuitively, I feel like you hit a bit of an impermanent loss penalty on doing that.
Yeah. Cool.
Sweet. Where were we? Oh, we were here.
Yeah. So, right. Just kind of right. We got the plus equals updating those. And we got ourselves the event there. And the event emits how much you're adding to each pool.
Yeah.
Cool.
Sweet.
Should we take a look at remove liquidity real fast?
Yeah. So this is sort of the other side of that kind of potential arbitrage thing that we were thinking about. So you would then have to remove the liquidity to cash that out. So again, so probably your address, the ID of the pool, and the amount of liquidity you want to take out. Okay, so checks that.
Actually, the truth is, because of time, should we just hop into swap?
Okay, is that here?
Because remove is probably just going to be kind of in first. But swap actually, it'd be cool to see how swap works.
All right.
All right, let's do it.
All right, cool. Swap logic.
2 ID in and in. Token in and all right. So if it's over total supply, no pair, storage pairs ID. If token in is not token 0, and it's not token 1, so then it's not part of the pair. Token in is address 0. So that's what you have to pass in if you're doing ETH. Amount in equals message value. Else token in safe transfer. Okay. So then amount out. So it calls swap in the swapper. And then if token in equals pair token 1, so it does a similar thing. Checks if it's ETH or if it's an ERC20. Then it affects the reserves appropriately. Otherwise, yeah. All right. Yeah. Okay, cool. So far, so good.
Cool.
Basically checks if it's 0 or 1 and updates the balances. And yeah, that's really it. I'd be curious to see the swap in the XYK. Yeah.
Swap. It's also quite succinct.
Okay, so what do we do? Pair.reserve 0, pair.reserve 1. Okay, it calls Helios for the struct. That makes sense. Gets the fee. If token in is 0, amount out, get amount out, which is right there on the bottom. And otherwise, it does it for the other token. Okay, so amount in, reserve amount out, and fee. So wait, amount in, token coming in, reserve amount in. What's the difference between amount in and reserve amount in on 90 and 91?
Wait, so amount in, this amount in, and then reserve amount in.
Yeah, and get amount out, the internal function on the bottom. Like the bottom. Yeah, that one. So on 90 and 91, it takes amount in, but then it takes reserve. Oh, the reserve, that's how much the reserves have right now.
Yeah.
As in that's the current capacity. You'll need that for the ratio. As in that's how much has been deposited to date. Now you're getting this amount in. So then you get.
So this is just to work out if we have an amount in based on these two figures, how much are we getting out?
And the fee. Yeah. And it auto subtracts the fee. And then it returns the amount out. And I guess the fee kind of stays in the pool.
Yeah.
It's interesting to see how they chart. Oh, yeah? So how do they track how many fees you've accrued?
Well, you just have the share of the pool with your LP token. And
and the fees are just sitting there. Yeah, okay, that makes sense.
Yeah.
Very cool. Part of the ingenuity of Uniswap's engineering in general is figuring out all the things they didn't need to figure out. You know what I mean? Well, it's like if we don't make this calculation, it'll still work out anyway because.
I mean, saying they didn't need to figure out. I think they figured it out. They just.
Yeah, you know what I mean. You don't need your Solidity code doesn't need to figure it out.
They didn't need to code that out. Or yeah. I get you.
Very, very cool. All right. So for once, I feel like we're actually not making crazy mad rush at the end.
Yeah. This was fun.
This has been so cool. Yeah. So awesome. Yeah, I'd love to see things like this get more traction. I'd love to see that data stuff used in creative ways also.
Yeah. Go follow Ross Campbell on Twitter. Dude's killing it.
Indeed. Cool.